Myself, Dr. Subir Gupta. Today, I will describe the mathematical problem of the banker's algorithm under the operating system subject. In this algorithm, we describe one predefined problem and explain how we will solve it. Okay? So, first we came to want to know what is the banker's algorithm. Suppose it is came from the bank word, you can easily identify with the name of the algorithm names. Suppose one bank started the day with 10 lakh capitals. Hands-on capital is a 10 lakhs. Now the first customer come and asking for the 10 lakhs. If bank provide the 10 lakhs to the first customer, then what's happened with the second customer? If second customer asking for the 1,000 rupees, bank have a zero balance. So the entire resource cannot be allocated for a particular person, or entire capital cannot be allocated for a particular person. So we enter the day, few percent are deposit the money, few percent withdraw the money. In that way, the resources are limited. Operating system allocate the resource depend on the situation. Okay. Now elaborate that concept with an example. Okay. And this is a common example for many textbook if you use it is easily available. Here the five processes P0 to P4. It is right down here P0, P1, P2, P3, P4. Resource type is 3. Suppose resource means monitor, resource means hard disk, resource means printer, resource means anything. Resource type is 3. Assume that the A, B, and C, where A have the maximum capacity is 10, so it is a 10 instance. For resource type B, the maximum capacity is 5 instance, and resource type C is the maximum capacity is 7 instance. Okay, that is given into the question. It is not the answer. It is the question. Okay. Also, they will provide one snap to you for a particular moment, like here. The allocation of the ABC and max allocation of the ABC and available allocation of the ABC. P0 already occupied 0 amount of A resource, 1 amount of B resource, and 0 amount of C resource. And max of A is 7, max of B is 5, and max of C is 3 can be allocated for P0. Or if P0 want to execute the process and terminate, then P0 requirement is 753. Similarly, P1, P2, P3, P4 all are given. And at this moment, free resource means which is not occupied by any kind of process. That is 332. It is given. Okay. Now I go for the next slide. Here we create a need matrix. Need matrix, the formula is max minus allocation. Please remember the max minus allocation. So we go into the previous slide. The max of A for the P0 is 7 and allocation is 0. So need matrix for the P0 must be 7 because 7 minus max minus allocation, it is a matrix subtraction only. So 7 minus 0 is 7. Here we write down the 7. Similarly, for B resource, 5 minus 1 already allocated to 1 and maximum requirement is 5. So we can easily say that the need is 4 amount of resource B for P0. Here we write down the 4. Similarly, for the C, 3 are requirement and nothing is allocated. So 3 minus 0, it becomes the need of the P0 is 3. So in that way, we write down 743. Similarly, if we calculate for the P2, it is 3 minus 2 is 1, 2 minus 0 is 2, 2 minus 0 is 2. So 1, 2, 2. That is the need matrix for the P1 for execute the enter process and terminate it. So we write down 1, 2, 2. Now we look on the P3, P2. It is a 9 minus 3, that is 6. 0 minus 0 is 0. 2 minus 2 is 0. So it is a 6, 0, 0. Now look here. It is 6, 0, 0. It is clearly visible. Now we calculate for the P3. For P3, 2 minus 2 is 0. 2 minus 1 is 1. 2 minus 1 is 1. So we can say it is 0, 1, 1. Now we check. Yes, P3 is 0, 1, 1. Now we go for the P4 and the final process. That is 4 minus 0 is 4. 3 minus 0 is 3. 3 minus 2 is 1. So it is a 4, 3, 1. Now check. It is a 4, 3, 1. That is the first part. That is, we have to calculate the need matrix. In Banker's algorithm, if it is come in the exam, then you remember that if you do it up to the need matrix, then there are some partial marking. If anybody are successfully calculate the need matrix, you get the part marks. Okay. Now we look under available 332. Okay. Now 332 are available. I'm not explain this one. I explain by problematic mathematical way. Okay. So first it is 332. Now you check how many requirement for the P0? 743. But 743 cannot be sufficient for 332. Our available is 332. If we write down, the available is 332. Then it cannot be satisfied P0. Then we check for the P1. Yes, P1 is requirement or need is 122. So P1 can easily satisfied by 332. So we first consider the P1. Okay. So P1 will be allocated. So our first sequence becomes P1. Here we write down the safe sequence. The P1 is the first one. Okay. Now, please remember, if one process is terminated, then whatever the resource that allocate that for particular process, that is now available for the OS. So there is the simple rule: request, use, release. So it is request for a particular thing, that is 020, and whenever it is received, it use, and after that it release not only the need, release also the whatever the initial allocation for the P1. So the new allocation becomes we just write down a plus. What is the allocation of the P1? 200. So now it is becomes 200. So what is the present available resources? It is a simple matrix addition. That means it is a 5, 3, and 2. Is it clear? Because P1 is terminated. So whatever allocated with the P1, that must be released. Now 532 can satisfy the P2? No, because P2 are asking for the 6 amount of A resource, but here available only 5 amount of A, so P2 cannot be satisfied. Now we go for the P3. P3 can easily satisfied by 532. So our next step sequence is P1 after P1. I just make it cross P1. P1 is already satisfied. Then we go for the P3. P3 are satisfied. P3 are satisfied. So we write down the next step sequence is P3. Okay. Whenever P3 are terminated, whenever the P3 are terminated, then P3 must be released 211 to the west. So new condition is plus 211, and what is our available? It is 743. Clear? Now 7 P3 is terminated. Now 743 can easily satisfy the P4. So P4 can be satisfied. So we check the next step sequence where it is P4 or not. Yes, it is P4. Clear? Now P4 release the resources, whatever allocate initially. That is 0 to 2. That is 0 to 2. 0, 0, 2. Okay. So we have to add 0, 0, 2 here. 0, 0. Now what is our value? Available resources value? 7, 4 and 5. 7, 4, 5. Because 7 plus 0, 7, 4 plus 0, 4, 3 plus 2, 5. 7, 4, 5. Now can it is satisfied the P0? Yes, it is A is 7, 7, okay. 4, 4 is okay. C is 3, it is 5. So we will satisfy P0. Okay. P0 is terminated. So our next sequence is P0. Clear? So definitely once again, uh, P0 release 010 amount of resources. So what is your current value? 7, 5, 5. Can we satisfy the P2? Yes, we satisfy the P2 because P2 only want the A resource of 6 unit. So our last part is P2 will be satisfied. So we check the step sequence. Yes, this P2. Now in this problem, if you face any kind of problem where you are unable to solve this matter, means any circumstance, any process are not satisfied, then we can say the system are not in safe state. Okay. And finally, whenever the 755 are satisfied the P2, then P2 must be release the resources. P2 is 302. P2 is 302. So 755 755, sorry, it is it. I do it once again. 755 plus lastly satisfied P2. Lastly satisfied, that means 302. 302. Now you simply add how many resources are available for the OS. 7 plus 3, it is 10. 5 plus 0 is 5. And 5 plus 2 is 7. So 10, 5, 7 resources are available for the operating system. End of the 5 process terminate. Now we go into the question. Please remember that value 10, 5, 7. Now go into the question. 10, 5, 7. Both are equal. So end of the all process, you will return all the resource to the OS. If you are unable to identify the subsequence, then it is the maybe under the deadlock. That is the Manker's algorithm problem, and that is the way out to solve this problem. I hope you understood everything. If you have any question, uh, feel free to ask me. Here I write down my mail ID. You just simply ask in this mail ID. I will answer you. I will answer you if you have any doubt. It's gmail.com. Don't know how much you enjoy, but that's end of Banker's algorithm, and I assume that you have no doubt. Well, if you have a doubt, feel free to ask me by mail. I already provide my mail ID to you. Thank you. Thank you very much.